Everyone, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today we are going to see about the ion exchange process. First is the demineralization process. So you can see the cross-section diagram for the demineralization process, where you have first a cation exchanger, then comes the anion exchanger, and you can see on the side you have a dilute HCl on near the cation exchanger, and near anion exchanger you have dilute sodium hydroxide. So these are present for the regeneration process, and the raw water is let into the first into the cation exchanger, where all cations that is present in the water is exchanged, and it goes to the anion exchanger, where all the anions that is present in the water are exchanged, and the water that is coming out of the this is a deionized water, where there is no complete ions are removed in that water. So let's go for the process. So water coming out of the anion exchanger is completely free from cations and the anions. This water is known as the demineralized water or deionized water. So the regeneration process, the cation exchanger resin can be regenerated with dilute acid. So after certain process of exchange, the resin will get exhausted. In that case, the regeneration process is done for the cation exchanger with the help of dilute acid, and in the anion exchanger with the help of dilute alkali. So you have the resin and you have the ion, 2H plus ion, where it is exchanged with that is the cation that is present in the water. In the anion exchanger, the resin can be regenerated with dilute sodium hydroxide, and you can see the resin, that is the anion resin, it is treated with the alkali, and where it is replaced the sulfate ion or the anion is replaced by alkali. So this is the regeneration process. So what is the advantages? Highly alkaline and acidic water can be treated by using this method. It produces water with very low hardness, that is only from 0 to 2 ppm. Disadvantages: equipment is costly, chemicals that are used here are expensive. Iron and manganese containing water cannot be treated because the regeneration is very difficult. So when these ions are present, so when they are going to be present in the resin, it cannot be removed easily. And next process is a zeolite process. So zeolites are naturally occurring hydrated sodium aluminosilicates. So its formula is Na2O, Al2O3, SiO2 and H2O. Natural zeolites are green sands which are non-porous. Synthetic zeolites is known as permuted. It is a porous and has a gel-like structure. So synthetic zeolite is represented by Na2Ze. The sodium ions which are loosely held in the zeolite are replaced by the calcium and the magnesium ions that is present in the water. So this is a water softening technique where, unlike the demineralization or deionization process, it is not going to remove all the ions. It's only going to replace the hardness causing ions. So process when the hard water is passed through the sodium zeolite, it's kept in a cylinder. It exchanges its sodium ions with the calcium and the magnesium ions present in the hard water to form calcium and the magnesium zeolites. So we can see that in the equation for the calcium sulfate, when it is treated with the zeolite, it is replaced. Okay, and the magnesium sulfate is also replaced with the zeolite. So the softened water contains a large amount of sodium salt which do not cause any hardness but cannot be used in boilers. Regeneration. After some time, the zeolite get exhausted, so the regeneration is done by 10% solution of sodium chloride, which is represented in the equation. So this is the diagram that is depicting the zeolite process. So the raw water is sent into the cylinder where the zeolite resin is present, the calcium and the magnesium salt that is present are interchanged with the zeolite bed, and softened water which contains sodium salts are come as the outlet. So the softened water will contain large amount of sodium salts, but they do not cause any hardness. Soft water obtained by this process is mostly used for laundry purposes. So water softened by this method cannot be used in boilers because it contains a large amount of dissolved salt, sodium salts. So when it is used in the boilers, it is going to deposit in the inner line of the boilers, the pipes, etc. So it is avoided over there, but it can be used for the laundry purposes because it gives a good lather with the soap since it's a soft water. So advantages. Water obtained by this process will have the hardness from 1 to 10 ppm only. The equipment used in this process is compact. No sludge is formed. Its operation is easy. The process is cheap. What are the main disadvantages? The turbid water cannot be treated by this method because it blocks the pores of the zeolite bed. Water softened by this method cannot be used in boilers because it contains large amount of dissolved salts. Acidic water cannot be treated because it affects the zeolite bed. So the iron and the manganese containing the water cannot be treated, and this process cannot be used for softening brackish water. That is, the brackish water will contain a huge amount of salt. So when we compare the zeolite process with the demineralization process, the zeolite it removes only cations. It removes both cations and anions completely. Soft water is produced by this process. Demineralized water is produced by this process. This method cannot be used to treat acidic water, and the demineralization process can be used to treat highly acidic or alkaline water. Zeolite process, water obtained from this treatment cannot be used in boilers. It contains large amount of sodium salts. Water obtained by this treatment can be used in high pressure boilers. Thank you.